Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the impact of elastic bodies and impact and types of impact. The outcome of today's session would be recall the concept of conservation of momentum for knowing the velocities and momentum before and after collision of bodies. The topic covered would be impact of elastic bodies, impact and types of impact. Topic learning outcome is understand the concepts of impulse and momentum and apply these in collision of bodies. First, let us understand what is the impact of elastic body all about. A collision between two bodies is said to be an impact if the bodies are in contact for a short interval of time and exert very large force on each other during this short period. Okay, so for understanding this statement, let us take an example of an accident that is been happening between two vehicles. Let us imagine that a car is going in one direction and in the opposite direction another car is coming in the straight way. When we consider the contact point of the cars that is being happening, let us say some accident is being happened, and when both the cars comes into contact with each other, then we can say the contact point is the starting point of the impact. We have seen in many practical cases that when some bodies or when the cars are traveling with some velocity and gets into contact with each other, they won't detach or they won't be moving away without being deformation at the contact point. That means they will apply some force on one another. The car on the right and car on the left both will exert forces on one another. That means the car, let us say car A and B. Car A will be exerting force on the car B and car B will be exerting force on car A. Then what happens? Because of that application of force, for a small interval of time, both the vehicles will be in contact with each other. Immediately after the contact, they won't be, within the next fraction of second, they won't be moving away. There will be some time for which the forces will be exerted on each other. That means the deformation will be happening after the collision. So these are the terms that are discussed in this statement. Let us see the statement once again. A collision between two bodies is said to be an impact. When we call it as an impact, if the bodies are in contact for a short interval of time and exert very large force on each other during the short period. Okay, so we need to understand that the forces will be exerted on one another for a short interval of time. That may not be for a long time, like 3 or 4 seconds or something. Maybe for a fraction of a second, but the forces will be exerted by both the objects on one another. It's not like one object will be coming and colliding the other object, and only the first object itself is applying the force. Whenever, according to Newton's third law, we all know, whenever there is some contact or some force that is being exerted onto the other object, then the other object also exerts some pressure and force onto the first object. And these forces which are exerted by each other may not be equal, depending on the moving capacity or the velocity or the weight of the object. All these considerations which are being considered, the force that is being exerted on one body to the other body may not be equal. But definitely when both the objects gets into contact with each other with some velocity, then with some force, the both will get into contact and they exert some forces on each other, and this exertion of pressure or force on each other will be for a short interval of time. That means there will be some time period on which the forces are exerted on each other. This phenomenon or this incident is termed as the impact. If the bodies are in contact for a short interval of time and exert very large force on each other during this short period, it is termed as the impact. On impact, the bodies deform first and then recover due to elastic properties and start moving with different velocities. As you have seen in many cases, let us say some object is moving in this direction with some velocity u, and another object is moving in this direction with velocity v. When this is happening, at some point both the objects gets into contact with each other. At this contact point, what happens, for a small interval of time that we have discussed earlier, they will be exerting pressure on one another, exerting force on one another. Then what happens, they get deformed. Both the objects will get deformed. In the second stage, this can be treated as first stage. In the second stage, both objects will be getting deformed, and after the deformation, because of the elastic property of the materials, once the deformation happens, because of the elastic property of the material, again it will try to all the elements will be trying to get to its original shape. So what happens, because of that property, again at the third stage, the deformation, not the complete deformation, will be cleared, and they get to the right in the real shape or the original shape of the objects, but maybe with some small deformation they will be separated. So these are the three stages that will be happening when an impact happens, right? In the first stage, both will be getting into contact with each other, both will be exerting pressure on one another or force on one another. Then the deformation happens. Deformation happening will be maybe that would be for a small interval of time. That would be the second case. And in third case, what happens? These deformed bodies will try to get to their original shape, and both the bodies will be separated. So this is how the impact happens in any scenario. Any objects that are getting into impact consideration, these are the properties. On impact, the bodies deform first and then recover due to plastic properties, elastic properties, and start moving with different velocities. The velocity with which they separate depends not only on their velocity of approach, but also on the shape of the object or body, the size of the body, the elastic property of the material, and the line of impact. Okay, the shape of the object, depending on the roundness or the flatness and all these things, the deformation or the separateness will be depend. And the size of the object may be a larger size colliding with a smaller size, or the same sizes colliding with each other, and all these things, the deformation will be happening. Then elastic property, maybe some if 100% elastic material is being present, then complete deformation will be recovered to the original shape of the material. But in universe, we don't have any 100% elastic material, not not a metal. In that way, the line of impact, that means the traveling of the bodies which we have considered, right? In the previous example, we have seen this is traveling in this direction, and in this straight way it is traveling. Or else, if this object is traveling in this direction and this object is traveling in this direction, the line of travel is like this. So the contact point will be happening like this at this contact point. Then what happens? The direction or the movement or the velocity of approach and velocity of separation, all these things will be different than the direct impact, right? So these are the cases where the impact is not dependent on only the velocity of approach alone, but also depends on the four factors which we have discussed. Now, if we consider the impact of elastic bodies definition, some important terms. In the four figures which we have seen here, A, B, C, D. these four figures are having different orientations and different positions and considerations for all the impacts. In these four figures, the impacts are being given as an example. You can observe here. In the first two figures, that is A and B, there is a small object and a larger object. Let us say these are the maybe some metal balls or any balls that are being, or any bodies that are being colliding, and the velocities are u1 and u2 for the bodies here as shown, and the direction in which they are moving, the directions in which they are moving, this is the line of impact. This is the line of impact that we need to consider. Okay, and in the figure B, you can observe that this object is traveling in this direction and this object is traveling in this direction, right? And this is the line of impact here, line of impact. So depending on the directions which the objects are traveling, we can see here in the figure C and D, you can observe here there is a ball. The example is given using ball and bat, and this is a bat where the centroid of this bat is somewhat present here and the centroid of the ball is somewhat present here, and the direction in which they are traveling is like this, and the line of impact is as shown here. And in second case, what happens? The bat is traveling in this direction, but the ball is traveling in this direction and getting into contact with this bat, and that is the line of impact of the bat, right? So as per the given nomenclature here, the terminology given is direct central impact, direct central impact, and this is oblique central impact. Okay, when the direct central impact is considered, so the traveling direction of both the objects are in the direct straight line. Where oblique is considered, the traveling of the objects are not in the straight line, but they are coming in different directions and getting into contact with each other. And that is the line of impact which we are seeing in the figure, right? And here the eccentric impact. Eccentric impact, that is, the centers are not in line. The centers of the objects are not in line, but the objects are getting into contact or getting into impact action here. And the oblique eccentric impact, again, the centers are not in line, and this traveling of the ball is in different direction than the traveling of this bat. Okay, so these are the terminologies which we need to understand. Now let us see the definitions of each and every terminology that is being given here. First one is line of impact. The line of impact is termed as the common normal to the colliding surface. Line of impact is the common normal to the colliding surface. Then direct impact. Direct impact is the term used when if the motion of the two colliding bodies is directed along the line of impact, the impact is said to be the direct impact, right? The motion of the two colliding bodies is directed along the line of impact. Here you can observe these motion or directions are along the line of impact. The movement of the object is along the line of impact. So the directions depends depending on the direction of the movement of the object. It is termed as the direct impact. Then the oblique impact. If the motion of the one or both of the colliding bodies is not directed along the line of impact, the impact is known as oblique impact. As discussed, here the oblique, the directions are not along the line of impact. Okay, here also the direction is different than the line of impact. So in these cases, we can say it is the oblique impact. Then coming to central impact, if the mass centers of colliding bodies are on the line of impact, the impact is called as central impact, right? As we have seen in points A and B. Here, the mass centers, you can observe here, the mass centers are along the line of impact. The mass centers are along the line of impact. Okay, so then Here second C and D figure, you can observe that the mass centers are not along the line of impact. Those would be the eccentric impact. So with this, you can observe here the eccentric impact. If the mass centers of any one of the colliding bodies is not on line of impact, the impact is said to be eccentric impact. Okay, so these are the terminologies which we need to consider in the concept of elastic bodies collision. Now let us see the Newton's law of collision of elastic bodies. This law states that when two bodies collide with each other, their velocity of separation bears a constant ratio to their velocity of approach. Okay, so this is the statement given by the Newtons, and it is termed as the Newton's law of collision of elastic bodies. We can say, or we can represent the statement with this equation, which is V2 minus V1 is equal to a constant into U1 minus U2, where we can understand that V2 and V1 are the velocities of second body, or we can say first and second bodies final velocities, and U1 and U2 are the velocities of initial velocities of bodies 1 and 2. Then when we simplify this, we can get the equation as V2 minus V1 by V1 U1 minus U2 is equal to a constant, and this constant is called as the quotient of restitution. So with this statement, Newton's law of collision of elastic bodies, we have defined a term, restitution, quotient of restitution, as the change in velocity of final velocities, let us say, change in final velocities to the change in initial velocities. That is termed as the quotient of restitution. So therefore, the term quotient of restitution is represented with the letter E, that is equal to V2 minus V1 by U1 minus U2. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.